All right, lesson 7.6 or section 7.6 specifically is going to talk about exponential growth and exponential decay. Now, we have a general equation for this thing called exponential growth. That's when that curve is trending upward, all right? So we have this equation that says y is equal to a times 1 plus r to the t. And this equation helps us to make calculations and predictions specifically based off of information that we determine represents exponential growth. Now remember, growth means that you have a value that is greater than 1 that is being raised to a variable power. Okay? So let's look at this first example. All right, we have population. The population of Johnson City in 2005 was 25,000. Since then, the population has grown. There's my key. I know I'm talking about exponential growth. It has grown at an average rate of 3.2% each year. The first thing that they want us to do is to write an equation. We're going to use this form here. Write an equation to represent the population of Johnson City since 2005. All right, so if I write this, I have y is equal to. Now, A represents my initial amount. My initial amount here is going to be 25,000. That's what the population was in 2005. I'm going to multiply that times 1 plus the rate, or in this case, the growth rate. But I never write a percent as it's written. I always change it into a decimal form. So this would be 0.032. So remember, you have to move that decimal 2 places to the left when changing it from a percent to a decimal. And then I'm going to raise that to the power of t. And the reason why I'm going to leave it as a variable t is I don't know how many years they want me to make the prediction. It could be 5, it could be 10, it could be 7, it could be 100. I don't know. So I'm going to clean this equation up, and I get y equals 25,000 times 1.032 raised to the t power. And this equation is the equation that represents the exponential growth of Johnson City. Now, if I take that information and I come to this second question, it says, what will the population be according to the equation? It's a predictor. According to the equation, what will the population be in Johnson City in 2015? So we have 2015, from 2005 to 2015, I know that that is representing a T of 10, or 10 years. So I go to my equation, and I say, all right, I've got y equals 25,000 times 1.032 raised to the 10th power. All right. Now, as you guys know, I don't trust my calculator. So when I pop my calculator up here, I'm going to focus on figuring out the exponential part first and then multiply that times 25,000. So here we go. We've got 1.032 raised to the 10th power equals. So that's what 1.032 to the 10th power is equal to. I'm going to multiply that times 25,000. And that gives me 34,256. What was it again? It was 34,256 people. All right? Now, let's take a look at another kind of exponential growth. Let's say you're doing an investment. So the Garcias put $12,000 in a savings account. The bank is going to pay 3.5% interest on the savings account. But something uniquely that they're doing is they're compounding it monthly. When you have a compounded interest problem, this is the equation that represents that. Now, if you notice, it's very similar to the other equation that we used before. But what makes it different is notice how there's this divided by n, and then we raise it to the n power as well. That part is how we represent compounding monthly. You can have compounded monthly, compounded semi-annually, quarterly, weekly, daily, and all those things are going to change it. They want us to find the balance in 3 years. Now, I did give you a little descriptor over to the side here of what all of these different variables mean. Okay? So here's what I know. In order to solve this, I'm trying to figure out my final amount. Okay? Or my current amount that I have after the compounding occurs. I'm going to start with my principal. My principal is my initial amount. That's $12,000. I'm going to multiply that times 1 plus R, which is 3.5%, written as a decimal is 1.035, divided by N. Now, N is the number of times that it is compounded per year. If it's compounded monthly, that would be 12 times per year. We're then going to raise that to the 12 times 3 because they want to find the balance in 3 years. 12 times 3 power. All right? So let's clean this up before we go to the calculator. We've got 12,000 times 1 plus, holy cow, I'm just going to leave it like that. 1 plus 0.035 over 12 raised to the 12 times 3 is 36 power. All right. So let's go to this calculator now. Clear it out. I know to find this, I have to operate my calculator in a way that makes sense. Now, inside the parenthesis, I'm going to take 1 plus parenthesis, because I have to do that division before I add, 0.035 divided by 12, close that parenthesis. So let's figure out what this inside part of the equation is, inside the parentheses there. So I'm at 1.00291666666, blah, blah, blah. I now have to take this part and raise it to the 36 power. So I'm going to raise it to the 36 power. Remember, that's the caret symbol for those of you guys. And now I'm at that. Multiply that times 12,000. And I get 13,326. $13,326. And because I'm dealing with money, I want to round it to the nearest cent, so that would be 0.49. So if you think about that, that's pretty cool. All I did was put money in the bank, $12,000. And within 3 years, that money grew without me doing anything else to it to $13,326.49. All right? So along with exponential growth, we can also see this thing called exponential decay. Now, exponential decay, it comes back to that original equation again, but notice the unique difference here. Instead of adding the R, we're now going to subtract the R. And the reason for that is the value that is raised to the exponential power has to be between 0 and 1 for it to represent exponential decay. All right? Now, how you know that it's exponential decay is a couple of things here in this example. The word depreciation. Depreciation means exponential decay. A second one, it says the original price of the tractor is $45,000. The value of the tractor decreases. Decreases is telling me exponential decay. And it's decaying at a rate of 12% per year. All right, so let's take a look. As an equation, I would have y is equal to the initial amount, $45,000, times 1 minus 12%. Well, that's going to be 0.012. Raised to the t power. Clean that up. I have y equals 45,000. 1 minus 0.12 would be 0.88 raised to the t power. And if you look right here, that number is between 0 and 1. So my equation is definitely representing exponential decay. All right? Now the second question says, what's the value in 5 years? So I'm going to take that equation, and where I have my t, I'm going to substitute in So now I go to my calculator again, and I have 0.88 raised to the fifth, get that answer, and then multiply that times 45,000. And that tells me 23,000, we're dealing with money again, $23,747, and I'm going to round to the nearest cent. So 0.936 tells me 0.94. That 3 became a 4. Now, if you think about this, guys, isn't this kind of crazy? I bought a brand new tractor for $45,000. In 5 years, according to the prediction equation, that exponential equation, it should only be worth $23,747.94. All right? That is very typical. All right? Hopefully this helps. Good luck. Let me know if you have any questions.